Hello.
Hi, okay, let us start to B and section B and C. Okay, let's look at section B. The most popular is RC and RL circuit. You can see that. Okay, let's look at that. Not every year, 18.4 most popular. That means the last section in the topic. State two differences between resistant and reactant. Okay, you should be able to tell me.
Resistance and impedance, Acha.
Yeah. Impedance, resistor and impedance. Yep.
Resistance is equal to the voltage divided by the current. Impedance is the vector sum of the resistance and the reactance.
No.
Huh?
Definition is the same. Resistance
No,
is
this
the
one
ratio.
differences what? Differences, not definition.
Differences of resistance is
Yeah.
the ratio of voltage to current. Impedance is the ratio of peak voltage to peak current. That's the difference. Then you can give your Z equals to square root of R square plus X square. X is the reactant of the components of circuit. Then the other one, resistance does not change the frequency of the voltage supply. Impedance is not constant, but changes as the frequency of the supply voltage changes. Okay? One depends on frequency, one doesn't depend on frequency. That is a 2 point, 2 mark, 1 mark each. Okay?
Okay.
Yeah, why I didn't.
Oh, Acha, exam so near. I'm getting almost scared now.
The reason you are stressed is because you are not doing your homework. That's why you are not prepared. That's why you are stressed. That's why I've been scolding you and telling you, you must do your homework. There's no shortcut. Tuition will not help you.
Do homework also very stressed to do so hard the question.
Because you have not been doing homework all the while. So you have what I teach you, you have forgotten. So now it's even tougher because you have to revise everything and it's very unproductive. After I teach you, you must do the homework to force it in. Then become like you. Just I have to teach you new topic. I have to learn myself. I have to do the question, then I force it in. Okay, that's your circuit. Resistor 2 ohm, inductor 5 millihenry. They are connected in series to your power alternating source. Current is given. I is in ampere. T is in second. Calculate the impedance. Okay, no choice. Calculate your reactant for your inductor. Put in your value. Then after that, Z equals to R square plus XL square. Okay. Part 1, part 2, determine the maximum voltage across the circuit. Okay, you've got Z. Right? Z, think of Z as your total resistance, if you like, in the circuit there. So to find your maximum voltage, you have got your Z. Then your maximum current is there. So you can calculate your voltage. Is I naught times Z. So I naught is 1.5. Z is this one. Okay. Anything? Any comment?
No.
This number 2, sorry, not number 1. Getting very careless. Okay, number 2. Electromagnetic coil of resistance 330 ohm. Inductance 5 Henry is connected to an alternating voltage source of amplitude. Amplitude means maximum value, 240 volt, frequency 60 Hz. Calculate the impedance. Okay, so your book make a mistake here. The answer depends on what value you use. Right? These two values are different. The book use these two values. So that's why my answer is going to be different from the answer. Right? Find your XL first, reactance. Okay, 2 pi, frequency is 60 Hz, F is 60 Hz, L, that's your L. Right? I use 0.5, follow your book. Then calculate your Z. Right? Your book use 300 rather than 330. So anyway, I didn't bother lah. It's a matter of just different value, that's all. Different answer. 330 Z XL, square that, get your Z. Calculate the root mean square current. Right? Okay, as previous question, you can see that if you've done one, you should be able to do the other one. B, root mean square current is root mean square voltage over Z. Okay, remember this is maximum. Right? How come? Oh, I know why I got it wrong already. Okay, amplitude means maximum. So I have to divide by root 2. That's why I got it wrong. You can use a calculator to calculate out. Have you got the answer? Yeah, very slow this part. Computer is very slow. Point 632 divided by root 2, 4.47. 0.447. Okay, the answer is different because of here. That value here. It doesn't matter as long as you know how to calculate it. Any comment? Okay, if not, let's carry on to the next section. Okay, these are answer given by your book. Okay, answer given by book because of the different value they use here. Okay, see, sketch the phasor diagram of the circuit. Okay, so that is your VR. That's your current. Current and VR in the same direction. There's a VL. Right? There's a anti-clockwise direction. That's all. Okay with that?
Okay.
All right, let's go to number 3. An AC source with root mean square voltage 20 volt is connected in series with a resistor or resistance 81 ohm and capacitor 22 microfarad. Root mean square current is 1.8 ampere. Calculate the impedance. You can see that everything is calculate impedance. So calculate your impedance is just your V over I. Right? Depend on what they are given. They are given your 220, given your current. So that's why you have to use this. Right? This voltage across the impedance. You have a current pulling through the impedance. 120 root mean square. This is also root mean square. 122 volt. Reactant of capacitor. So how will we calculate the reactant of capacitor? Right? We are now doing backwards, that's all. Same as previously, but doing backwards. Right? VC, V square minus VR square. Right? We can all times your I, that's why we cancel all the I out. So it's Z square minus R square. So Z square, we have calculated that out. R, that's your R, 81 square. So we got 91.2. Right? The difference in value is probably because of the significant figure we use. Okay, any comment? If not, let's go to part C.
Yeah, can go to part C, sir.
Frequency of the source. Okay, that's your R or VR. Right? That's your reactant for capacitor or VC. That's your Z or V. Right? We are just using backwards. Normal. Right? You calculate your capacitive reactance for capacitor. Then go to the formula 2 pi SC. Right? Cross multiply. To find your F, take your XC down, put in your value. Right? Your XC, 2 pi. And then capacitance is here. And calculate your frequency. Then you want to calculate this angle. You can use any cosine, tangent, or sine, whatever is convenient. Right? Z, we have already calculated. Your cos phi or cos theta is up. It's just your R over Z. Okay. As I say, the difference is because of number of significant figure we use in our calculation. That doesn't really matter. Okay. Okay, let's carry on. A sinusoidal voltage formula is given, is applied to a current which consists of a resistor, to a circuit consists of a resistor of resistance 50 ohm and an inductor of inductance 0.2 Henry as shown in the diagram. Calculate the impedance. Right? You can see that almost the same. Go and calculate the reactance. Okay, know how to read this one. This is your 2 pi F, 120 L is 0.2 Henry. And Z is R square plus X square, square root that. Right? So R is 50 ohm. So X is this one, square that. Determine the maximum voltage across the inductor. Okay, maximum voltage, you have to calculate your current first. That's your peak voltage, that's your Z. So peak, and we can obtain from here, 140. Right? Your Z, you calculate it out. So that's your current in the circuit. Right? You calculate peak, that's your peak current. And your inductance, the I times XL. The voltage across the inductor is I times XL. I is your I. your XL. This is your XL. Okay, can? Okay, if no question, let's go to part C. Calculate the phase angle and sketch a phasor diagram. Right, that's your phasor diagram. That's your I. That's your VR. That's how it rotates anti-clockwise. Then your triangle, VR, and then right, VL. Right, these are all given or given or given. For XL, we already calculated. Z, we already calculated. Okay, we want to find this angle. As I say, can use whatever you prefer. Right? I use cosine. So it's VR over V. What am I doing? Not VR. If I use VR, then I must use your VZ here. Right? The V. I'm not using VR here. I'm using R. Okay, anything you are not clear, ask. Okay, quiet.
No, I'm okay, sir.
R is 50. Z is 55. Right? Use your calculator. Okay, let's go to part C. Okay, you can see compare the A, B, and C. Only certain years it didn't come out lah. Only the repeat paper lah. Repeat paper they don't come out sometimes. Almost every year, either B or C. Okay, a power source produces an alternating voltage given by the equation where V is in volts, T is in time. Determine the frequency. Right? It's straightforward. Compare with general equation. 2 pi F is just your 120 pi. Calculate your F. Determine the root mean square voltage. Define the root mean square voltage is equal to the direct voltage that produce the same heating effect in a resistor as the alternating voltage. Determine the root mean square voltage. Right? Root mean square is peak divided by root 2. 156 over root 2. Okay, anything not clear?
Okay, sir.
If not, let's carry on. Determine the power source with root mean square. Right? 140 root mean square. 50 Hertz is connected in series with a capacitor, resistor, as shown in the diagram below. Determine the impedance of the circuit. You can see that. Find the reactance of a capacitor. Put in your value. Right? 50 Hertz for frequency. 2 pi. C is that. That's your C. Right? Convert to SI unit. Calculate out. Then Z is R squared plus XC squared. Put in your value. Right? That's your resistance. Calculate the root mean square voltage across the capacitor. Okay. Calculate the root mean square current in the circuit first. Right? When you calculate the voltage across here, you already calculate your XC. Now I have to calculate the current through the circuit first. So you use your V divided by Z. Right? V is 240 divided by Z, that is 5.1. We got 4.71. Right? Voltage is just your, instead of resistance, we use reactance, that's all. Put in your value and calculate out. Determine the phase between the current in the circuit and the supply voltage. Right? Draw your triangle. This can be R or VR. This can be VXC or VC. This is your Z. Right? This is a vector diagram, remember? So XC we have calculated. Z we have calculated. So you can use whatever you want. Or R is also given. So sine, I use sine. So it's XC over Z. XC. That's your XC. That's your Z. Okay. Okay, let's carry on. Define the root mean square current of the alternating. Okay, what's the root mean square? Yep. Didn't study yet. All this must be in your fingertips, in your head. It is the AC that has the same heating effect in a particular resistor as the direct current. A filament bulb is connected in series with a sinusoidal voltage supply. Explain how the brightness of the bulb changes if the frequency of the supply is increased, but the root mean square voltage remains constant. Any feedback? Anything you want to try to answer for me?
Not sure.
You're not ready for exam yet, my friend.
Mm.
You're not putting in the effort.
No.
Resistance doesn't depend on frequency. So it
Yeah, I
doesn't
give up already, sir.
give up so easily. Still got time to study. Current is
2 weeks, what am I going to achieve, like, sir? 2 weeks.
no point in giving up. Still got time to study. It's just that so far you haven't put in the effort. Resistance of filament lamp is independent of frequency. So as the frequency change, I'll still say constant. So I is still constant. Heating effect produce the brightness. So P is I square R. Since the root mean square current is constant, the heating effect is constant. So also the brightness. Okay. Anything not clear? Okay, let's carry on. Okay, we are given the filament bulb 100 volt, 40 watt. Right? This is always root mean square value. It's connected in series with the resistor and sinusoidal voltage supply. Root mean square 240 volt, frequency 50 Hz. If the bulb is lit with normal brightness, calculate the resistance of the bulb. Okay, so this is basically testing your DC circuit. Formula V square over R. Okay, so we want to find R, V square over P as 100. Right? V 100 square, P is 40. So it's 250 ohm. Resistance of the resistor. So how are we going to calculate the resistance of the resistor? Right? This is just a DC circuit. Right? You can either find the current. Right? From here, you can find the current is going to 40 P is 40, V is 100, is 0.4. Then you can find the, right? You know the total PD across resistor and filament is given by that. So it's 240 minus your 100. It's 140 volt. So that 140 is across the resistor. You can calculate your resistance V over I. 140 over 0.4. So it's 350 ohm. Okay. Anything not clear?
Okay,
Still got time to put in the effort. All you need to do is a pass or to improve on your grade, 1 or 2 grade higher. It's not impossible. You still got time to study. Must have confidence.
or retake only lah.
Retake is difficult already. Unless you start all over again. How to retake? They don't allow you to retake. Unless...
No. First semester, second semester they allow. Third semester they won't.
Oh, like that lah.
Yeah.
Retake also will be susah for you because you got 3 semesters to work to study how to study. Okay, the filament bulb in C is better to do well this semester. Don't think of repeating. Filament bulb is C. Above is then connector in series. Concentrate on each topic. After study, review through all the formulas you need to remember and then try the question. That's the most important. Try the question. You cannot answer, look at the answer. Give you some idea, then try yourself. Right? Understand how the answer works, how the outer work, and then do it yourself. No need to look at the answer already. That one will force it in. That's why I'm learning. I have to relearn again. All these things happen. It's not in the A-level syllabus. Filament bulb in C. Above is then connected in series with capacitor. And the same voltage supply. If the bulb is in normal brightness, calculate the capacitance of the capacitor. Okay. Right, you have got the root mean square current you have calculated earlier. And then you can calculate your VC. Right? V is given. VR is also for the bulb. You have already calculated. Put it in there is given. Right? This is the voltage supply 240, 218. Then you can calculate your XC. Right? Before you can calculate your capacitance, you have to calculate your XC. VC over I root mean square. 218 over 0.4. 545. Then calculate your XC. Right? Frequency is given. Frequency is given as 50 Hz. Refer to your note earlier. Right? X is this one. Put in there. Calculate out. Phase angle. Right? Whatever you want to use, I use sine. So it's VC over V. Right? VC is 218. V is 240. Refer to your question A. Right? 5. State one advantage of using a capacitor instead of resistor to regulate the current in the alternating circuit. Yep. What's the advantage of using a capacitor? Yeah. Instead of using two resistors, you replace the resistor with a capacitor. So what's the advantage? No heat is lost in a capacitor. Resistor, you got heat loss. Right? In AC circuit, there is no power loss in the capacitor, only loss in the lamp. That's the advantage. Okay, let's do the last question. Waveform of sinusoidal voltage, which is supplied to a resistor, is shown in the graph below. Sketch on the same axis of time the curve for IR as a function of T, and the curve for instantaneous power PR as a function of T. That's all. This graph. Right? May want to draw in the voltage graph also. Okay. Just label it off. This is IR. This curve is IR. This is PR. Okay, you have to follow the graph lah. They have given you two cycles. We have to do 2 cycles. If the resistor is replaced with an inductor, sketch the same axis on another graph, the curve of current as a function of time, and the curve of instantaneous power as a function of time. That's all. Okay. There's a voltage. Right? There's a current. There's a power. Right? More memory work. The key to remember is your V will leads I. That's how you check V and leads I. Correct or not? Correct. V leads I. Okay. Above 120 volt, 60 watt is connected in series with a resistor R and an alternating current supply of root mean square 230 volt and frequency 50 Hz. Determine the value of R so that the bulb glows with normal brightness. Okay, you got PD across the bulb. So now you want to find got a total PD across a circuit. So it's 230 minus that. That is your PD across that resistor. Okay, so power is just your current from this equation divided by V. P is 60, voltage 120, so 0.5 ampere. So R is V over I. Right? We have calculated that. Okay, mind this is a series circuit. So it's 110 divided by our current. Get to 220 ohm. That's your current. Any comment?
No, sir.
State whether the resistor or inductor is more suitable to be used to regulate the current in the alternating current circuit. Justify your answer. Yep. Same as what we did for capacitor just now. Any comment? Right? These are all the values we have calculated. Sorry, we have got determine the value of R. Right? We have done that. So the total resistance is 230 divided by the current total resistance. Then your Z is your R square plus ZL square. Right? Z is your total resistance, if you like. So you want to find your ZL. Put your ZL the other side. Here, I'll square the other side, sorry, and then square root that, put in your value. Right? 160 minus 240. Right? Same as your DC, I said that you cannot subtract directly. You have to square that and then take a square root using Pythagoras theorem. Then after that, put in your value. Right? XL is 2 pi FL. 390, 2 pi 50, 1.25 Hertz. Inductor has no resistance. So a pure inductor is more suitable as it does not dissipate heat. It is not resistant. Just react only. But the power supply the energy, the other part return to the power supply, that's all. So no energy is lost. Okay. You're completed already. All the best to you. So you still got 1 or 2 questions you can ask. Just give me a ring and then we can have a Zoom. As long as it's less than half an hour, we won't charge you. Okay?
Sure, teacher.
Yeah. Anything?
No, still got until number 4. What? Just finish it lah.
No point in me doing for you. You are wasting your time. You don't put in the effort. That's why I keep on scolding you. You are wasting your time. You won't learn anything from me doing it for you. Right? You're wasting your time. Right? Impedance is just the opposition. You are asked to define impedance. Impedance is opposition to alternating current in the circuit due to the presence of resistance and reactance. It can be defined as peak voltage or peak current through the circuit. That's all. Right? You're given the voltage formula. V is in volt, T is in second. Voltage supply across the pure inductor is 220 microfarad. Determine the root mean square voltage. Right? Peak voltage is given you. This one is direct, that's all. Memory work, that's all. Simple calculation, V0 over root 2. 340 from here. Root 2 is 240 volt. Sorry, this one should be number 1. Derive an expression for current that flows through a capacitor. Right? Go to Q is CV. Charge stored in capacitor. Then differentiate it. You want the current. Differentiate, you got I is dq dt. So differentiate this equation. Your C is the one that is constant. What am I doing? Why is it not showing up? Okay, so that is your equation. You differentiate this one, your C, this is your C value. That's your V value. That's your V value. Differentiate that, you got 314 coming out. And the sign become cos 3140. Then calculate the value out. That's your answer. Determine the reactance of the capacitor. Okay, 2 pi FC. In case, get you to remember the formula. 2 pi F is 314. That's your capacitance. Calculate out. For the resistor is connected in series with a capacitor so that the current is reduced. Determine the value of the resistance of the resistor, which must be connected in order for the root mean square current to be reduced to 2.4. Right? Root mean square voltage is given. Right? Refer to your earlier part, beginning. So you got the current. Then you can calculate the total resistance or the impedance of the circuit. Right? 240 divided by your root mean square current, is 100 ohm. And your Z is R square plus XC square. Right? You want to find R connected in series with the inductance. So 100. Right? That's 100. XC is 14.5. So it's 98.9 ohm. Same like DC, except you cannot subtract directly. Right? You have to remember that the Z is the total resistance, that's all. That we have used Pythagoras theorem. Determine the phase angle. Same. Right? Can use whatever you want. I use R, that's my R, and that's my Z, right? Which is my V. Right? That's my phasor diagram. So from there I can calculate my angle, phase angle. Okay. Any comment?
No, sir.
Okay. They're completed. All the best to you. As I say, you need to ask, you clarify anything, can still text me or phone me. We can start a Zoom. So all the best to you.
Yes, sir. Okay.
After your exam, can take a few days off, and then after that can tell me when you want to start the class.
Start 2 semesters.
So you don't know when your third semester is starting.
No, I think if I'm not mistaken, next week after the exam itself, they are starting already.
So fast not 1 week break
Okay. That 1 week, right, teacher? The Monday and Tuesday they will start sem 3, but then Wednesday, Thursday, Friday is chutti, I think. Yeah.
Oh, like that Okay. Anyway, you give me a text when you want to start. It's up to you. I will stop here. So all the best to you. Have a good rest.
I have any question, then I ask you.
Yeah. Any question you can ask. I will stop here.
Any subtopic I still not clear, then I ask.
Anything you want to ask. You have to work very hard already. There's still hope. Up to you to work already.
No, like 2 weeks. Not sure.
Review through the formula.
And do a lot of questions.
Yeah. Can still review a lot of things there. Okay. All the best to you. Bye-bye.
Bye. Thank you, teacher.